part 2 of your Unit 8 test review. Let's get started. Alright, I'm skipping number 21 and going on to number 22. This one's really not hard, but complicated, so please pay attention. Alright, so when you see something like this, that means that this whole angle right here is 43 degrees. And just this little part is 27 degrees, okay? That's what that means. Alright, that's very important. A lot of you missed this on the last test, okay? So, first, I'm going to use a bunch of different colors for this one. There are two triangles that we have to look at, alright? First, there's this little one, right? You guys see this little triangle, itty bitty? We want to find this, okay? This is the first thing we want to find. Alright, so we're going to do that. We're told that this length is 13 inches. This is 27 degrees, and we're trying to find this. Alright, let's call this A. Okay? So, this is the opposite, and this is the hypotenuse. So we're going to use sine of 27 degrees equals A over 13. Multiply both sides by 13. We get 13 times sine of 27 degrees. I'm sorry, guys. It keeps happening. Anyways, okay, and that is sine of 27 degrees equals 5.9. According to my notes. Alright, next, we're going to look at the big triangle, right? No good. We're looking at this triangle, right? So we want to find that. Alright? There we go, this marker works. Alright. So we're trying to find, once again, opposite over hypotenuse. So this is sine. Let's call this B. So sine of 43 degrees this time equals B over 17. So we do 17 times sine of 43 degrees equals B. So we end up getting that B equals 11.6. Alright? But that's not what we're looking for, right? We're not looking for that. We are looking for this right here. We'll call that C. Alright, so in order to get C, you're going to subtract this from this. So you're going to do 11.6 minus 5.9, which you are going to get to be 5.7 inches. Okay? So like I said, this one's a bit complicated, but it's not hard, okay? You just have to do a function twice, alright? Let's move on. Alright, let's look at number 23. Alright? If a 100-foot pole, so this is 100 feet, casts an 88-foot shadow, okay? 88-foot shadow to the nearest tenth of a degree, what is the angle of elevation? So we're looking for this, of the sun, right? Which is over here somewhere. Okay? Alright, we're going to use an inverse function for this, right? Because we're trying to find the angle. If you're trying to find the angle, you're going to use an inverse trig ratio. And if you're trying to find the length of one of the sides, you're just going to use the regular trig ratio. Okay, so for this one, we're going to use the inverse. And we're going to use tangent because it's opposite and adjacent. So, inverse tangent. Do not say tan negative 1, okay? Inverse tangent of opposite over adjacent, 100 over 88, equals, you put that into your calculator, and you're going to get 48.65. So the answer is 48.65 degrees. Do not forget your degree symbol, okay? That is important. All right? Let's look at number 24. This one's a little different. From the top of a vertical cliff, 60 feet high, all right? This is 60 feet. The angle of depression of an object that is level with the base of the cliff is 43 degrees. How far is the object from the top of the cliff? Okay? So, we're looking for this, right? Now, in order to find this, this is important. We need to know that this is parallel to this. So now we can use alternate interior angles, right, to determine that this is also 43 degrees. So now I have this triangle here, right? And I can just figure out x using, let's see, opposite over hypotenuse, so sine. Sine of 43 degrees equals 60 over x, which we end up doing x equals 60 divided by the sine of 43 degrees, right? And for that, we get 87. It doesn't tell us what to do, or what to do as far as rounding. So 87.9 feet. Don't forget that. All right, so that's using angle of depression. All right, we're going to look at number 26 now. I'm skipping 25. All right. The steps to the front entrance of a building. Here's our building, and the steps kind of look like that, right? So the steps to a front entrance of a building, sorry, the steps are so much bigger than the building, are to be torn out and replaced by a ramp for wheelchairs. Alright, so this would be the ramp, right here. Alright, by a city ordinance, so like a law, the angle of inclination for a wheelchair ramp cannot be greater than 9 degrees. So what is the minimum distance from the entrance that the ramp must begin? Okay? So remember that the bigger that this line is, right, the smaller the angle of inclination is going to be. Keep that in mind. So the smallest this could be, since it can't be greater than 9 degrees, that's like it can equal 9 degrees. So let's calculate it that this is 9 degrees. Alright? And it's asking, by the city ordinance, the angle of inclination for a wheelchair ramp cannot be greater than 9 degrees. What is the minimum distance from the entrance that the ramp must begin? Okay? So that's asking us for this right here. Alright? So it tells us that this, by the way, is 1 meter. Okay? So now we set this up, and we just need to figure out what x is. We're going to use opposite adjacent tangent. So the tangent of 9 degrees equals opposite over adjacent, 1 over x. So x equals 1 divided by the tangent of 9 degrees. And that answer is 6.3 meters. Okay? a woman is standing 10 feet away from a large cabinet. So this is our cabinet, right? This is our woman, all right? And this is 10 feet, okay? She has the cabinet open, and her line of sight to the top shelf, let's say that the top shelf is over here, is 37 degrees, or well, let's make her a little bit shorter. All right, her line of sight is 37 degrees. So if this is her eye, all right, we have this imaginary line, right? And she, by the way, this is 5 feet, right? All right. So how high is the top shelf from the ground? She's looking up at an angle of 37 degrees, right? So this is also 10 feet, all right? So now we need to find the height of the cabinet, or this height of the cabinet, all right? From the height to her eye up to where she's looking, all right? This is 5 feet, right? Okay, so let's find h, which is just this right here. So we're going to use tangent, right? Opposite and adjacent. So tangent of 37 degrees equals h over 10. So 10 times the tangent of 37 degrees equals h, which equals 7.54, all right, approximately. So that's just the height of this, and we want to know how far the top shelf is from the ground. So now we just add 5, right? Because that's what this is. So plus 5, we end up with 12.54 feet. That's your answer. Okay? Let's look at 28. Explain the relationships between the sine of 55 degrees and the cosine of 35 degrees. Well, 55 and 35 are complementary. And the sine of an angle is equal to the cosine of its complement. So, sine of 55 degrees equals the cosine of 35 degrees. Okay, do you guys remember that? That's important to know. All right, so now we're skipping 29 and we're just going straight to 30, which is the last one that we're going to do. This is going along with what we talked about before. Solve for theta in the equations below. So the cosine of 40 degrees would equal the sine of its complement, right? So the complement of 40 degrees is 50 degrees. The sine of 29 degrees is equal to the cosine of its complement, which equals 61 degrees. The cosine of 30 degrees is equal to the, or 32 degrees is equal to the sine of its complement, which is 58 degrees. And the sine of 9 degrees is equal to the cosine of its complement, 81 degrees. Okay, so those are the problems that I'm doing, and you will have access to the key in class, and I might post it online. So good luck studying.